Alright, so welcome back to a new Advent of Code Day, and today we have should be a pretty simple problem as well. And I read through the description, and I think we will solve it in like an imperative language, for instance Odin, because it was requested a few times, and I thought, okay, why not? Let's try it. Even though I saw that Odin looks like a language made for like game development because it has a lot of integration with graphics, but let's try it because I saw it has if you scroll a bit down you see for loops, and I'm like, okay, if it has for loops and arrays, then it should be good for this day. So let's take a look at day 4 problem. So we have some story about the for today, right? And it's like the interior for Ceres monitoring station, and I think this is like another day from another year, right? And here we search for the chief, whatever, still the same story, and a small elf wants help from us to fix some word search, and the word search is our puzzle input, and she wants to find the Xmas words, right? So it's like a crossword, right? And you can search on diagonals, on reverse lines, normal direction lines, up down, down up, and that's the idea, right? Any directions basically. So our puzzle input is probably gonna be quite big. Let's see. Not that big, but well, we can solve half of the problem by doing just Xmas, and we see it's 225, and then X and AS, it's anyway. So we have our puzzle input. It's quite big. It's gonna be at least 500 matches, so we can keep that in mind because we saw that while control Fing. And yeah. So here in this one, Xmas occurs 18 times, and here we can actually see how it occurs because you can see it's even diagonal reversed, so that's pretty weird. So what do we want is how many times does Xmas appear. Now I'm gonna be curious about the second part. I have no idea what it could be, but usually it's really cool when you get like can figure out what part 2 is gonna be like based on first part, but here I don't see like how you would make this problem harder. So maybe it's something that doesn't make the first problem harder but makes sense with this input, right? So you have to think about it like that. Usually when it's like day 10, 12, that's when you can make part 1 harder by saying, okay, you did it 10 times, now do it 10,000 times, right? So yeah, but for the first part, that's what we have to do, is search for these words. And I mean, I think if we have a 2D array, should be pretty easy because we are gonna just look in all directions for each index, right? Look on a radius of 3 or 4, I guess, and see if we find all of the Xmas's. Okay, so yeah, let's get right to the code. All right, so to start out with Odin, I just copy pasted this example here just to see how it's gonna generate hello world, and this would be the command to build. I mean, building would be even easier if you just do Odin run dot and it runs, but I want to build a main executable, and I guess the reason why is just to have the same kind of format with all the other days. I think it's better. So we have this make file. I say make, and I can even make clean make, and then we still have main, right? So that's the idea. So first thing we need to figure out how to do in Odin is to read from stdin. So how do we procedures? It has a bunch of description. I really like that about this language already. And as I said, yeah, it's makes me think like it's a combination between Golang and Rust, because it even uses runs or rune. But you know, it makes sense because Odin, it's Norse mythology. Anyway, so how do we read a string? I'm just gonna quickly glance over this stuff. I don't see it, but maybe if I search for stdin, I have to stop that. Like that always scares me. I don't know why. Okay, read. Odin read stdin. Read input. Not. I guess read input is his function. So straight up using os.read. Okay. So I guess don't mind me. I guess, but Odin read all from stdin. It is reading a file line by line, but OS read entire file. It even has allocator. That's so it's like a combination then between. Okay, so maybe it's in OS. Maybe we have something in OS, right? So let's see, os dot read entire file from handle. So I'm even curious about how the errors is gonna be, or error. Wait, how? Oh, so this gives you like, okay, interesting. So from handle it gives you success boolean, and this one it gives you error. So it really is like a combination between read entire file from handle. And what I'm curious is how about sending in file descriptor of stdin or something. So os.stdin. Note bill. Okay, whatever. So I guess it's a handle, right? So this should read entire file from stdin. Makes sense? Makes sense. And it's gonna give us, so if we just look, oh, should I close this one? So if we just look at how variables, right? So you can see variables, you don't even need to write anything. You just put the variables equals to. Okay, so if I, okay, makes sense, yeah. So if I want to create variables, we can just say axis and okay, and we use a double colon or colon and equals, and I guess it says here that it infers the types. So do I need I don't need semicolon. Okay, so honestly I don't really care about the error. maybe we can just ignore it. And let's see if we can print, I mean, axis is bytes. So can we convert axis to a string? Let's import string. So I can just say, so now this is a string, our input, and this is axis, or I guess data, it makes sense. Yeah, true, data. So that's how we read our input, right? So I'm just gonna run make main, and let's paste input Day04 into it. We actually get the input. Perfect. So now I can see this iterator approach. Buffered IO. I mean, you know, I like the lines. So here we process a line. Okay. So what I would like to do with this this iterator is to parse it into a list of strings, if it's possible to have that. So I would say like for instance, puzzle. Can I say it's gonna be a string array? Is that a thing? Expected type. Okay, so then I'm curious how you declare arrays in this language then, because that's what we need. We need an, okay, so you put it the other way around. Oh, this is a hash map. Okay, but it means that the array was before that. Okay, here's the array. So we can have a dynamic array, which is kind of what we need. I guess. I mean, we can even try. Okay, let's see. So I can say then infer the type. Well, let's see if we can just make it empty. So it's a string array. Can I puzzle? No. Dynamic. So now it's a dynamic. I guess you cannot have. Oh, you have. Oops. So append is a function. So it really is like Go. Appending to a dynamic array. So you use append. Okay, interesting. And here you can append many. That's cool. Okay, so that's how we append our stuff to the puzzle. Can I have maybe a proc get puzzle? It's a proc. And do you specify like the return or something? Like this? And I can just return puzzle. And then we have puzzle is equal to get, oh, I have to get puzzle. Okay. so I have to keep saying it's dynamic. Probably like you saw here, you can even defer deleting the data or something. I mean, I saw it's the default allocator, so, and here we defer deleting the puzzle. Already forgot how to do a hello world, so let me just copy this thing again. So can I have something like puzzle.length? Okay, it didn't like that for some reason. But yeah, that's pretty nice. Okay, so it's good for learning, right? Those snippets. So puzzle.len, but doesn't. Okay, fine. Could be better, but let's see if we get the. Okay, so it looks like it actually reads the entire thing. So it has like manual memory management. That's kind of meh, because but it's still like C basically, so nothing special about the memory. Yeah, the only thing is that you can use different allocators just like Zig. So but even in C you can create that illusion, right? You can, like I did in ds.h. Okay, so we have now we have a list of strings. Honestly, can I have line fmt.println line 0? Can I access a character? Oh, interesting, and it prints it as a number. I mean, if it makes sense, maybe I could say print it as a character, right? Oh, it doesn't like that. Huh. So if I do like x is equal to x is gonna be a what? It doesn't want to show. Okay, whatever. So the next step would be to actually solve part 1, obviously. So part 1, we want to, so here we get all the lines, and I'd like to get maybe the width and the height of the map. So can we have that? Can we do something like height is equal to len puzzle, obviously, and width is gonna be, can I do len puzzle 0? Oh, and you have to declare them with the thingy. Okay, so both of them should be height width. Can I print them like that or something? Whatever, let's see. Okay, so it's a square matrix, perfect. Not that it matters, but yeah. So we are gonna have a function now, or procedure, part 1, and this one is gonna take as arguments, can I make it const for this one? Like I send something like a reference to this this arrays, right? So I don't, and then 2 integers for the lengths, and we return how many we found. Okay, so will it work? let's see. So I call part 1 with puzzle height width, and we get answer 1. And here I say part 1 answer 1. Okay, it doesn't like that. Okay, so you still have to like use another weird. Okay, so you still have to use dynamic, even though I want to send it as const chart pointer, or you know what I mean. Anyway, so let's see. Okay, so we get it compiles perfect. So at this point, wait. I didn't give them a name. I'm like, because of stack I have PTSD and I forgot about the names. Okay, puzzle with height. I was like, what? Oh, what the fuck? Too many values expected. Wait, but then how do I whoa, wait a second. Wait a second. Yeah, undeclared, but how do I get the variables? Oh no. Let's see an example of making a function. Like, I was like, what the fuck, why does it work? And then, oh, I forgot to put the, okay, but yeah, how, I guess you can do, okay, perfect. I guess you can do like in C, just declaring the header, so you can not put the, oh, so you can do it like this, like both of them are integers, right? So it's more like a data structure tuple. Okay, whatever. I don't like that, but probably some people do. Okay, so for the first part, right, we just want to iterate for loops. So if we go back to for, we can try to do that. So I'm gonna do, so we said height, so AH is how many rows we have. So I'm gonna call it rows and calls, just because it's easier for my small brain to reason about it. So for row is equal to, and since we are searching for Xmas, I'm actually gonna start at 4. No, shit. I guess it depends, right? We start at 0. I guess it depends on what the search is. Right. So I should be less than rows, or I guess row should be less than rows, and row plus plus equals 1. We are not in Rust minus minus, but in this language. Okay. So column is the same thing, but here it's calls and here it's call. Okay. Xmas. How are we gonna do this? Can I take a slice out of, so we need to do all the possibilities, right? So let's comment them, right? So a line in this direction, a line in the reverse direction, column, okay, I already lost, column in the down direction, column in the up direction, then we have like this in the down direction, right? Like this in the up direction, like I'll say that again, I've already forgot. It's not vertical, not horizontal, the in between. I guess it's said here. Horizontal, vertical, or diagonal, or even overlapping other words. Like that's not even important. So diagonal down, but you know, tilted to the right and to the left. So we have 8 cases only. So line both direction, column up or down, and diagonal the 2 diagonals, up or down. Okay, so I think we only have these ones. So the easiest ones, as you even saw here, you can just search and find all the matches. So it's 3 matches here, X, M, A, S. I guess it's only one the reverse. Okay, so you get the point. So for the line, what I would hope it's possible to do is puzzle and we get the row. So we get the line. Wait, it tracks that? No. So that's how we get the line. Now, question is, can we so my idea is going to be starting from the current X and Y, let's say, we look in all of these directions. So we look to the right, then we look to the left, and so on. So that yeah, it kind of makes sense. Imagine we are gonna look in like a radius of 4 around our position. That's what I'm trying to go for. So here, for instance, for this line, is it possible to have something like from the column to column plus 4, and this is going to be like slice. Okay, and let's try to print. So return 0, and let's try to print the slice, and let's see if it's actually possible to have this kind of slice, or if it's gonna just die. Nice. So we can do that, but you can see here that we are out of bounds at some point and we get deleted. So that's because this check can only work if column is less than cols -4. So we can only do this check in this case, this one, because we don't want to go over. Let me just create a TMP file with this input. Okay, so let's dump that TMP in there. So you can see last thing on the first line is xmas. Okay, so we can go even one more step actually. So here it's equals to that, right? That's what I wanted to check. Okay, so Yeah, because we want for more items, and if you think about it, if you add 4 to this one, like this is the limit, but it's not equal to its this is the less than strict less than, so let's just say that. So we get the right slice. Perfect. So can we now just compare the slice to Xmas? So let's have a counter, or answer is going to be 0, and that's what we are going to return, the answer. So here, if Xmas is equal to slice, can I do answer plus equal to 1? That would be pretty nice. So we can do that. Okay, so we should see 3 of them. Only 2 of them? I thought there are 3 Xmases. Fuck. So 1, 2, 3. Let's say I also print the... Okay, and that's why, I mean, I like the idea of do, but that's why it's better to just use curly braces, because sometimes, oh, I want to do a debug, so I have to change all of this stuff. So let's do column and row. So 04 and 59. 04. Okay, so I print the column. So row 4. It even skipped the first column. What? It even skipped the first column. Or I mean the first row. What the fuck? Okay, so let's say, let's see. Let's see. So here we have the column, right? I guess, I mean, the line could be generated outside of this this stuff, because, you know, that's what it makes sense. But I don't see that as being the problem. So what is actually the problem? Let's print a row, column, and then something like, I don't know, like slice. So every time we encounter something, we just print it. Okay, so why is it cooked in the beginning? Why is the first line destroyed? That's an oopsie. That doesn't look right. Did I do something in TMP? No. That's really strange, because I didn't. Is this destroying the... I mean, I don't see how. Let's print puzzle before and after. Like, how can that even matter? Okay, so it's even before that. What the fuck? mess. Yeah, why is the first row like that? That's pretty fun. Let's see the lines. Okay, like that doesn't make any sense. So the lines look good. Okay, what the fuck? Let's not delete the data, like fuck that. Okay, so doing the delete actually was fucking with our data. That's lame, to be honest. I have no idea why, but it is what it is. Okay, so we actually get the right answer, but only for this direction of the lines, right? So how about the opposite lines, right? How about that? Well, we need something similar, but the column needs to be greater or equal to 4, right? Because we want to look back, and we want to look back. Let's think. So I said actually I want to look back until column +1, and here it's gonna be -3, so this should be. And the real question, do we have a reverse? Odin string reverse. I mean, oh, that's a cool one. You can just say reverse like that, but we don't really have a reverse. Okay, that's not X and A. Oops. S. I'm pretty sure Vim has something to do that, but let's see. So the reverse direction should be one more, so we should see 4. Wait, it was 2 more. X M A S. No, it's only one more, but I can see one here too. What? X M A S. Yeah, it's 2 of them. All right, so that's good. We got the reverse direction too. Okay, now it's gonna be interesting for the columns, and for the columns, what I think I have to do actually, let's see, because we need to build we need to build the column in a different way than the line. Right, but we have to keep the same kind of logic here. So if we want to look down, we need to have an if statement. Okay, I'm just gonna do here because that's cool. We have to basically check that we are with a row less than or equal to rows -4. Okay, and I guess this one can be here because it's, well, actually I mean it's fine, there's the whatever, but maybe it's gonna be more intuitive for the columns. So here we need all the lines, like line 1, line 2, line 3, and I mean line 0, which is this one. So we need all of these lines, I would say. Right, I mean, we can just do a for loop. That should be easier. Or we can just so it's this row and the column. So we actually got the character, right? We actually got the character. And if you think about it, we can just say +1, +2, +3. And that's how we build the column instead of a line. Right, so column is, I would say, probably a string. So we can just compare. Right, so maybe it makes even more sense actually to call it slice. And let's do the same thing here as well. So you can see how here, well, if it works to slice on this one, does it work to slice on the row as well? That's the real question. So would it work to just say that? Right, that's the real question. Would this thing work? Because if it does, then that's pretty cool. You know, it's like the NumPy arrays where you can slice anything, right? So yeah. And for the last kind of check, we do the same thing here with the row -3 and row +1. Right, so this should give us the columns as well. Except here I need to say Xmas in reverse. How I usually write the reverse, if you noticed, is I type the same word, but I go, instead of going to the right, I go to the left when writing it. You know. Oh shit. Index 3 is out of range. What do you mean? Let's see. Let's see what this puzzle, whatever gives us, because I'm curious. So it actually gives us, oh shit, it gives us a list of lines. It gives us a list of, which makes sense if I think about it. Yeah, makes sense. So then the question is, I guess it means that the easiest way is to just do what I did before, right? So if I undo until then, just to copy it, I cannot really think about a better way, honestly. So this should do it. And here, for instance, we have -3, -2, -1, and 0. So oh, can I just say this is a string? Just to not have that weird oh no, I cannot. What can I put? I cannot put that as well. Shit, how do I thought so apparently this gives us an U8. Odin U8 array to string, or I guess U8 array is just string, right? So if I say U8 and I build a U8 array like this, it should be fine. Or is it? Okay, and then I say string. Right, so it's the same thing as here, I guess. And the cool question is, can I just have a string like this? Or do I need to specifically say first it's an array and then it's a string? I need to say first it's a U8. Okay, I mean that's kind of okay because it's more strict. We get 8. So on the vertical we have 1, 2. I cannot really count. Xmas, this is the third one. I swear I cannot. And there should be another one, vertical. I guess I counted this one. I counted this one. Then it's this Xmas. And that's kind of all I see, honestly. So where is the fourth one? Wait, how many were for the first part? I think there were oh shit. I think there were 4, right? Oh no, 5. Okay, so 3 more. It sounds good. 3 more. It sounds good. Okay. So now I'm curious about the diagonals. So diagonal to the right and down. Should we have both cases? Now that's a good question. Yeah, we should have both this case and this case. So we should have both conditions from the if statements. Okay, now that's cool. We are gonna see how we write the end for a condition. So we have both of them and probably it's end. Okay, yeah, that I think that's it, right? So why we have both conditions? Because we go down and to the, well, maybe it would have been more correct to write it like this. Right, so we go to the right and down to the right and up, left down, left up. So in this case, we are gonna use something similar to this to find if we find Xmas. And instead of adding +1 to the row, we also add +1 to the column. That's all you have to think. Like, okay, we add, because we are going on a diagonal, and that should be it for the diagonal. Then how about this to the right and up? Right, we are going up, which means we need this check for the columns instead of this one, or no, for the rows. Actually, I'm just gonna, instead of call, I'm just gonna put a vertical bar, and here is gonna be like this. Right, it shows better the directions. Okay, so that means if we go up, we cannot extend the 3 row. So it means that for the rows, so columns are still gonna be +1 because we are going to the right, but rows need to decrease. Oh, and actually, to no longer compare with this crap, I can do another trick, and let's start it from now because it's gonna be better. So we go up, right? We go up. This is the case when we were going up. So to go up, we have to do here -3, -2, -1, and 0. So to no longer have to compare with reversed of Xmas, but I guess, you know, it's in the spirit, so why not? I wanted to just put the items in the reverse order, but this should be going to the right. You can see column increases and the row decreases, or I guess, wait, I thought, yeah, row decreases, but we search for the reverse. So actually row increases, right? But we search for the reverse. But it increases from a -3 offset, so yeah. But is that right? Because column goes from left to right, but row, so I guess this one is, I mean, it is this case, right? Going in this direction of that. Well, let me just, oopsie, let me just delete these bars. So we want to see to the right and down. So to the right and down, it makes sense. To the right and up. To the right and up. I guess on the diagonals is a bit more tricky because we have 4 diagonals, but I always want to look for something like, because you can see that here I'm looking for the ordered one, and here I look for the reverse. Right, when I look back, I look for the reverse. So that's the idea, so that I only find them once, because if I look for both of the cases I'm gonna find them twice, so I don't want that. So when we look back, we look for the reverse. Yes, it makes sense. That's true here. So here, for instance, we look for the reverse, but we have to look in the right direction. So that's okay. So to the right and down, to the right and down. So here both of them increase. Let me just zoom out so that we can see everything. So here it's columns minus 4, cannot be. So here I want to look starting from this corner down, right? So here we were looking in the down direction, and now I want to look it's a bit weird. Yeah, the diagonals kind of are annoying. So I guess diagonals that go down, yeah, but for the diagonals it's weird because there are more cases, right? So for instance, we have xmas going this direction, but we can have xmas going the reverse direction. So I guess, wait 1 second. So if I look only for, let's say I do the following. I look to the right only for xmas and to the left only for xmas. Yeah, I think that makes more sense to do it like that. So for example here, I mean, that's what I'm doing actually, but since I'm too lazy to just write the same thing, I'm just searching for that. So here, for example, is the same thing, but maybe it would make more sense to put them like this. So it's in the reverse, so that we can see better that we are actually looking for this word instead. Right, and even here, it's like a row, column, column, -1, column -2, right? And column -3, and we get xmas. And the first one is just the slice, because we can just do that, right? So we look in all directions, but only for the word xmas, because the reverse is gonna be inferred from this search. So for example here, we are looking in the right up direction, so that's a row column, row -1, column +1, row -2, column +2, and row -3, and we are looking for xmas again. So if you think about it, it could have been Xmas in the reverse order, but yeah. Right, I think that, hopefully that's true. Okay, so we look to the left now and down, so let's just copy paste this case. And here column needs to be greater or equal to 3. And if we look down, column increases, or I guess row increases, but column needs to decrease. So here it's probably -1, -2, and -3, right? And then we look to the left and up. So which case is this one? Column is greater than 3, row is greater or equal to 3. So here both of them should decrease actually. So let's see if we run this thing. We get 18, and that's actually also the answer. So yeah, the idea is, let's try to not look for the reverse. And if you, I mean, I could just open up GIMP and show you my idea. So let's say we make a screenshot. I don't know. Let me just, can I? Okay, it would be really ugly. So if we have like this point, wow. If we have this point and we look up this direction, like all of these 8 direction, it's 8, right? 1, 2, 3, 4, 5, 6, 7, 8, right? And we find here it was Xmas, right? It could have been the reverse of Xmas in this direction, right? But we found it like this, so we only found it once, so that's why we only look for that. So let's see if that actually works with the actual input. I mean, I said it should be at least 500, and it is. Actually got it. Whew. I mean, it was a bit more difficult to get the solution. But hopefully this makes it more intuitive on how I thought about it. And I wouldn't say, like, the syntax of the language was pretty easy, so it was straightforward, like programming in C. No, I couldn't see any issues with that. But let's see what the second part is like. So for the second part, we find that this isn't actually an Xmas puzzle, it's an X space mass puzzle. So we are supposed to find 2 mass in the shape of X. That's okay. Alright. So what we have to do for this one is to search for these patterns. Right. I guess we can use our same function, kind of, and we search for AS, AS, AM, and AM. Right? But we have to find all of them, right? So we won't use a counter, we will use all, and if all of them are true, then we increase the counter. So that's how I think we can achieve the search for it. So irrelevant character, I think that's it, right? So in this example, an Xmas appears 9 times. Okay, so that's what we have to do. Use our same function, but instead of Xmas, we search for these characters. And yeah, let's go to the code. Okay, so let's just copy part 1. I'm just gonna copy it. Okay. And what I'm gonna do is rename it part 2, obviously. And as I said, we are no longer looking for the lines, so we can remove that. We are only looking for the diagonals. Right. And I'm gonna have an all is equal to false first. Or I guess it should be actually true. It should actually be true. And here we are gonna do the following. We are gonna say, so left down, it's the AS case, AS. Right, AS, so we only look for 2 characters though. So let's delete everything and we are looking for AS. So if this is not equal to AS, then all is equal to false. Alright, all is equal to false. I mean, we can even say like all is equal to all or that stuff, or I guess and that stuff, but we can say all is equal to all and AS is equal to slice, right? We can say that, but I think this makes it more clear for people. So then here we are going to do something like this. All right, we are looking in the right and the up direction, so we search for AS again, so we have the same condition. If we don't find AS, we just fail. Then again we decrease these by 2, and now we are looking for AM, so we are looking left and down, so we are looking for AM. And again, why are we looking for AM and not MA is well, we started the center, right, with row column, and we move row +1, so down, and column -1, so left. So we get the next character, which is AM. Right. And here it's the last case, which should be also AM. But question is, okay, so I wasn't I thought this can be rotated. I mean, they can be written forwards and backwards, but does that matter? That's the question. Will it matter? So here, if all do answer plus equals to 1, let's see if it actually matters. Oh, I forgot to actually call the function. So let's see if oh, so they can be written in any order. Okay, so then I guess a cool trick, well, or AM not equal to slide. We can do this actually. But problem is we cannot have SAS or MAM. We need to find the mass, right? So right, this might give us more answers than correctly. So 16, right? Because we find SASs and MAMs basically. So how can we then I guess we could as well just combine the opposite diagonals and look for a mass and then look for the other mass. Right, so what I mean by that is when we go right and down, what if we also do this case at the same time? So, right, and instead of just this, we put puzzle row -1, call -1. So we start from top left and we go bottom right. And if we don't find mass or Sam, we say false, right? And then we go on this direction. From puzzle row +1, column -1, and we search for mass and Sam as well. All right, so basically, it's a comma. So here we are going like this. So this is the center, and we take this character, and this character, and we make sure it's Sam or mass, one of them. And then we go from row +1, so this direction, and make sure that these characters are Sam or mass. I think that makes sense. Okay, now that's insane. So let's have okay, like OK1 is equal to false, OK2 is equal to false. Maybe I'm doing something wrong here. So if we have mass or Sam, we say OK1 is equal to true, and if we have mass or Sam on this diagonal, OK2 is equal to true. And here, if OK1 and OK2, then we increase the answer, and we get 9, as it said here. So let's see what happens if we pass in our input. We get less results, which, I mean, makes sense probably. And we actually got part 2 like much faster because we already had all the, let's say, infrastructure built from the part 1. So yeah, kind of neat. You know, like, I cannot say anything about I almost said Zig because it looks to me like it's just like Rust combined with Zig combined with Golang. So yeah, but it was pretty nice experience to program with it. Like, I'm pretty sure you can do a lot more stuff, but probably a lot more stuff based on graphics, right? Because I can see a bunch of like on the front page of the language it says a lot of about graphics, so I'm pretty sure you can do. It's a good game development language probably. But yeah, so that's kind of all for today. We were able to get both parts in first try. That's always good. So we'll see next time. Like, maybe I'm also planning to use OCaml. Maybe, I don't know, hopefully if tomorrow is going to be an easier day, we can try functional programming again. If not, yeah, then the first time Dijkstra appears, I'm gonna use probably Python or JavaScript. Like, let's not even. I don't want to, uh, redo the Haskell experience with Dijkstra. That was insane. Probably like Rust when it's gonna be a complicated day, or Golang, or even Zig, and also C, because yeah, like C, Zig, Rust, Golang, they look, they are kind of the same as Odin, so it's gonna 100% be easy to solve hard days with them. Even Python and JavaScript. So yeah, let's see something more fun maybe tomorrow in the next day. So a more esoteric language. I'm not even gonna go to brainfuck. Like, that's not a good idea. But yeah, maybe like OCaml and other interesting languages we can see. So yeah, let's see in the next one. So see you.